So, good morning to all. Today, we are going to see, in the previous class, we have seen already what are the boolean laws we require and what are the theorems we require to minimize any given boolean expression or any boolean expression. So, already I told you in the previous class. So you should thoroughly study and come to the next class. Then only we can minimize the any given expression if you remember the laws and theorems. So basic theorems are two theorems we require: duality theorem and De Morgan's theorem. And laws means each and every law we are going to use. So according to the requirement. So I will just recollect those theorems. So De Morgan's theorem states that the complement of any switching function can be obtained by interchanging and with or with and every literal with its complement. Here literal means the alphabet which we are using, A, B or X, Y something. And duality theorem states that dual of any function obtained by and with or with and. So that is called the duality theorem statement. And here we will not change any letters, only we will change the arithmetic operators. So that is about these two theorems. Next. So this is the question. Everyone pause this screen, note down the question, write the truth table and also draw the logic diagram or schematic diagram for the given boolean expression. So f1 is equals to x plus y dash z. First take this expression, try to solve this one. So pause this one and note down the question, try to do that. So already we have seen truth table for AND or NOT gate. For each and every logic gate we have seen the truth table. So likewise we need to write the truth table here also for the F1 output. And what are the inputs here we have? Actually X, Y, Z, but here they have given 3 inputs we have. So how many combinations we are going to get for 3 inputs? 3 different inputs we have. So there exist how many combinations? 8 combinations will exist. So for that purpose first we need to write the combinations of this. Then we will write the y dash, then do the multiplication of y dash and z, then do the OR operation of x with y dash z, then we will get the f1. So I already told you, just pause the screen and note down the question, then you start playing. So try for at least 5 minutes. Okay. So the faculty who are there, so I am asking them, please pause this slide, give them 5 minutes time. So after that, continue the video. So next write the truth table. So now we are going to see. After this, first of all, I didn't mention any truth table here. So you can write the truth table easily now. X plus y dash z. Next, how to draw the logic diagram. See here, we have y dash and z. So try to complete the truth table mark. Okay. Next x plus y dash z. Wherever we have the one, then we are going to get the f1 expression. Okay. I think it is clear to you. Right. So now, how to draw the logic diagram or schematic diagram. Circuit diagram is different. Logic diagram or schematic diagram both are same, but circuit diagram is different. Circuit diagram means we will represent in terms of transistors. Here logic diagram or schematic diagram means we will represent in terms of logic gates. So here for y dash and z, which logic operation we need to choose? AND. In place of x, y dash z, which operation we need to choose? OR operation. But before that we have the inputs as x, y, z. Right? And here we require y complement also. So take the 3 inputs x, y, z. Take down 3 inputs x, y, z. Here I didn't mention the logic diagram also. So first of all, take the x, y, z inputs. Then take the inverter for the y only. See here I am showing the inverter to the y only. This is the logic diagram for the F2, but I am explaining the logic diagram for F1. Okay, you can understand easily. Okay, take the inverter for the y input, then you will get x here. Don't put inverter here, we are forgetting F1. Okay, so I will try to draw in the paint, then it is easy to people. So I'm going to take 3 inputs. So X, Y. So please excuse me if the straight line is not coming as straight. Okay, next I need to write here X, then here Y, then here it is Z. Okay, so now here what is the output here? Y dash or Y bar we can call, right? So now what is the first gate we require? AND gate. Shapes I require. I'm not able to do the shape. Okay. So this is the output Y bar Z we got. So what we need to do? Take this X, connect it to OR gate. Why? Because we have X plus Y dash Z. So what is this? F1 which is equals to X plus Y dash Z. So this is the logic diagram for the given Boolean expression. So I think this is very clear to you people. Okay. Yeah. Try to finish the truth table. Then go for this logic diagram. Okay. So now I am moving to the next slide. So what is our next question? F2 is equals to X bar Y bar Z plus X bar YZ plus X Y dash. If you have any doubt, mark your doubt, how it is coming, where it is coming, where it is coming, why it is here 0, why it is here 1, why this logic gate here only. So if you have any doubt regarding this, please mention your doubt there only with pencil or pen according to your wish. I will clear your doubt when I am coming to you people in the offline mode. Okay. So try to finish this. So first of all take the 3 inputs X, Y, Z. Next do the X bar, Y bar, Z bar need not require. So X bar, Y bar. Then complete X bar, Y bar, Z, X bar, Y, Z, X, Y dash also. Then do the OR operation of these 3. Then we will get the F2. Now here we may get 2 types of logic diagrams for this. So why? Because here X bar Z we have come in this X bar Z we have common. Here also X bar Z we have common plus X Y bar. If you take the X bar Z in these 2 expressions, X bar Z multiplied with Y bar plus Y. What is Y bar plus Y? Boolean law. Y bar plus Y. It is equals to 1. So hence the expression is X bar Z. So you can directly draw the logic diagram for these expressions, that is 3 AND gates, 2 OR gates, that is also okay, or 3 AND gates, single OR gate which will have the 3 inputs, that is also okay. Otherwise simplified expression. Always try to simplify the Boolean expression which is given, then try to reduce the number of logic gates as minimum as possible. Here inverter gates we require 2 inverters for X bar as well as Y bar. Okay. So I think I am very clear to you, and this is the logic diagram. So 2 inverter gates for X bar as well as Y bar. Here X bar, Y bar, 3 AND gates. So they have chosen only 1 OR gate. Otherwise you can take 2 OR gates also for these 2 1 OR gate, and output of this again connected to this, that is also correct. Okay. So try to reduce the minimum number of gates, or try to reduce the number of gates as minimum as possible. Next, see, this is also related to the same problem, but here we reduce the number of gates Previously we have 3 AND gates, now that is reduced to 2 AND gates. So this is the preferable one compared to the previous one. Okay, so any Boolean expression, first try to minimize that Boolean expression with the help of the laws or theorems, then try to draw the logic diagram. First write the truth table, then draw the logic diagram. So I already told you, whenever I am giving the question, just pause that question for 5 minutes, then write the truth table, then draw the logic diagram also. Okay, so thank you very much. So next I am going for the next question. So this video will stop here only. I will try to share the PPTs for the next class.